Another type of ionic compound we'll write the formulas for are those involving polyatomic ions. On the back of your periodic table, the left-hand side, you're going to see a list of common polyatomic ions and their charges. So we're going to use the same strategy, the swoosh and reduce method, for writing these formulas, but one word of caution. When we look at formulas for polyatomic ions, we're going to notice that they're found in parentheses. That is to help remind us that we cannot change anything within the parentheses. If we did, it would no longer be that polyatomic ion. So we're only going to add subscripts outside of the parentheses. Okay, so rubidium, Rb. We look at the periodic table. We see that rubidium is in group 1A. That means that it has one valence electron. It's a metal. It's going to lose that. And we'll end up with a 1 plus charge. When we look at the back of our periodic table for MnO4, we see that that polyatomic ion is permanganate, and permanganate has a 1 minus charge. We're going to crisscross the charges like we did with the previous example, and then we're going to rewrite the formula dropping ones and pluses and minus signs. So we end up with Rb MnO4 in parentheses. So we're leaving that polyatomic in parentheses. So we have our formula for rubidium permanganate. Notice something interesting. It's going to be a tip that will help you later. We ended up with a 1 plus and a 1 minus charge, and we did not write any subscripts for our formula. Anytime, here's the tip, anytime you end up with the same number for the positive and negative charge, so a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, you end up writing your formula without any subscripts. All right, so looking at our second example, we have strontium. Strontium is found in your second column, 2A group. So it has 2 plus charge because it's a metal. It's going to lose those 2 valence electrons. And then chlorate, when we look at the back of our periodic table, we're going to see that the formula for chlorate is ClO3 and that it has a 1 minus charge. We're going to crisscross, and you do need to show the work here, crisscross those charges and then rewrite your formula. Again, with these ionic formulas, if needed, you would reduce to its simplest form. And with our examples that we have here today, they are already in their simplest form. Okay, and that is how we are going to write formulas for compounds that involve ionic or polyatomic ions.